Hey class, so this is going to be a short demonstration of what we talked about in class, more in depth. I'm only going to go over one example, but it's pretty much all the same once you've gone over it a little bit. So, when we're thinking about box fill, there are numerous things that we have to consider. How many wires do we have exiting the box? So, we have wires that enter this conduit here, and then they exit. Do we have any wires that are passing through? So they enter this conduit, and then they exit this conduit without terminating or stopping or loops or anything to that degree, just straight across. Do we have any loops? So they enter this conduit, they go up, they go down, and then they go out through this conduit. Do we have any clamps? So those would be referring to for non-metallic wire. And any hickeys. Now the hickeys are generally threaded stubs that would come through that knockout there, and they would be used to support something like a ceiling fan or a large light. And then our grounds. Now, for any wire that enters and then comes out is counted once. Any wire that passes through, enters here, comes out here, is counted once. Any wire that loops is counted twice. So enters, comes up, goes down, and then goes over. Clamps are counted once. Hickeys are counted once. Devices such as, that's not a device, there's a device. So this device would be counted twice, and grounds are counted once unless there's more than 4, and in that case each additional ground over 4 would be counted as a quarter of the original number. So let's go through this box here. So the grounds are counted once. So we have one ground entering here, one ground entering here, one ground entering here, and then one ground coming off the ground screw. But the grounds are still counted once. We have 3 white wires. We have 3 black wires. And then we have 3 red wires. So that gives us a total of 10 wires. Now, each wire, in this case, is a number 14. So that means that its cubic fill is going to be 2. So, when we take the 10 and when we multiply it by 2, we get 20. Now, that's just for the wires alone. The yoke, let's say we took this switch right here and we had it in here, that would be counted 2 times the largest conductor. So the largest conductor is 14, so that's going to be 2 times 2, which is 4. And that is all that we have in terms of devices or wires entering this box. So our total number for the fill of this box is 24. Now, to figure out the availability of this box here, we have 2 options. We can either actually calculate it, or we can look in the code book. This box is a 4x4 with it being 1.5 inches deep. And the code book says that box has a cubic inches of 21. This mud ring here is a 3/4, and stamped on it right here. Let's see if I can get it so you can read that. There you go. That says 5.5 cubic inches. So, with the mud ring and the box, we have a total of 26.5 cubic inches. And as we just calculated, our wires and our one switch is going to be 24 cubic inches. So they do fit in the box nicely. So now let's consider conduit fill. So this conduit here is a 1/2 inch non-metallic flexible conduit type B. And if we want to figure out how full we can put this guy, we sort of have two options. Our first option is if all our wires are the same insulation type and size, we can just go to Annex C, conduit fill and tubing, and then look up our type of conduit and how many wires. But since we have bare grounds along with insulated wires, we have to actually count them separately. So these insulated wires are going to be THHN, and everything's going to be number 14. So I'm going to be writing this down, which is why you're going to hear me pause. THHN, number 14. So let's start with figuring out the area of this number 14 here. To figure that out, we're going to go to Chapter 9, Table 8, Conductor Properties, and we're going to look at number 14 wire size. We're going to go across to where it says area, inches squared, and it says 0.003 for a solid number 14 wire. Write that down. Great. And we only have one of those. Then, since all our other wires are of the same size and same insulation type, we can go to Chapter 9, Table 5, and look up THHN. Here we are. And the approximate area for each number 14 wire THHN type is going to be 0.097. 0.097. So now that we have that, we can calculate the total area that our 4 wires are going to take up. 1, 2, 3, and 4. So we have 3 wires multiplied by 0.0097, which gives us 0.0291. And then we have 1 wire at 0.003. When we add all that together, we get 0.037 3, 2, 1 for our total area of the 4 wires here entering this 1/2 inch non-metallic flexible conduit. Now we have to figure out how much area is actually available in this conduit for those wires. So that's going to be chapter 9, and it's going to be in the tables. Non-metallic flexible conduit. Type B here is saying that a 1/2 inch conduit 40% would have 0.125 inches squared in terms of its area. So 0.125. So that means that obviously, because 0.125, yes, 0.125 is more than 0.0321. So it means that this 1/2 inch conduit here is not full yet. We could put more stuff in there, and that's how you would calculate the fill for a conduit.